Hello. Today we are going to start the next lesson, that is probability. We'll start with the synopsis where you will learn some interesting things. First of all, there are some events which you must know. Under these events come like any trial or tossing the coin, throwing dice, playing cards. We will discuss about all these events. Now, suppose if you take the case of coin, a coin has two sides, head and tail. If an event consists of more than one coin, the coins are regarded as distinct. Like if we are tossing two coins, the two coins are completely different. We'll consider in that way. Then when you throw a dice, on a die, there are 6 faces marked as 1, 2, 3, 4, 5, and 6. Suppose if we have more than one die, all the dice are treated as different dice. Coming to playing cards. A pack of cards have total 52 cards. I will paste these 52 cards picture. So these 52 cards I have pasted here. You can see total 52 cards. First of all, we will consider the spade cards. The spade cards are these cards. These all are spade cards, in which we have one king. This is one king. One queen card. Here one queen card. One jack card. One jack card. One ace card. This is the ace card. And 2 to 10 cards. 2, 3, 4, 5, 6, 7, 8, 9, 10. Next, we will consider the club card. I will use a different color. So we'll see club card. The club card is here in the first row. These all are club cards, in which we have one king, one queen, and one jack. One king, one queen, and one jack. Then one ace, and again 2 to 10 cards. So 2, 3, 4, 5, 6, 7, 8, 9, 10. So total here we have 13 cards. Club cards, total there are 13. In the same way, spade cards also, total 13 are there. Next, we will come to diamond cards. So these are diamond cards in the last row. Again, you have one king, one queen, and one jack. And then one ace card over here. Then 2 to 10 cards. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Total, there are 13 cards. Finally, we have heart card. So these are heart cards. In heart cards, again, one king, one queen, and one jack. One king, one queen, one jack. Then one ace. And then 2 to 10 cards. 2, 3, 4, 5, 6, 7, 8, 9, 10. Total 13. So 13 plus 13 plus 13 plus 13. Total 52 cards. This is all about cards. Now, We can talk about a random experiment. What is random experiment? An experiment whose outcome, what will fall, cannot be predicted. When you toss a coin, whether you get head or tail, you can't tell. When you throw a die, whether you get 1, 2, 3, 4, 5, 6, you can't tell. When you pick up a card by closing your eyes, you can't tell which card you will get out of the 52 cards. So all these are random experiments. So these experiments can be repeated several times under the same conditions, and you may get different outcomes. Under the same conditions, when repeated, you may get different outcomes, or you may get same outcome. Next is sample space. What is sample space? The set of all possible outcomes. That is sample space. And N of S. Usually sample space set is denoted by S. N of S is number of elements in S. For example, when you throw a die, or first we'll take coin. So sample space will be head and tail, and N of S is 2. When you throw a die, the sample space will have 1, 2, 3, 4, 5, 6, all possible outcomes, and N of S is 6. If 2 dice are thrown, then the sample space will be having 1, 1, 1, 2, like that, up to 1, 6, then 2, 1, 2, 2, like that, up to 2, 6, and so on, 6, 1, 6, 2, up to 6, 6. So total in this sample space, 36 elements will be there. N of S is 36. So if 2 dice are thrown, N of S is 6 square, that is 36. If 1 die is thrown, 1 die, it's not dice. So if 1 die is thrown, N of S is just 6. If 3 dice are thrown, N of S will be 6 cube, that is 216, so on. Similarly, if 2 coins are tossed, then the sample space will have HH, HT, TH, and TT. That is N of S is 4. If 3 coins are tossed, sample space will have H, 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 T, H, 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 T, H, 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 T, 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 H, T, H, T, H, T, T, and that's it. So N of S will be 8. So when 1 coin is thrown, N of S is just 2. When 2 coins are tossed, N of S is 2 square. When 3 coins are tossed, N of S is to Q.
Like this you can remember. Similarly,
If 3 letters are put in 3 envelopes, then the letters we will take L1, L2, L3
and envelopes,
E1, E2, E3.
then in sample space,
The possible things you will have is L1 can be put in
E1,
or L1 can be put in E2, L1 can be put in E3. Similarly, L2 can be put in E1, L2 can be put in E2, L2 can be put in E3. L3 can be put in E1, L3 can be put in E2, L3 can be put in E3.
these are the possible outcomes. So N of S will be 9.
Similarly, making 2 digits without repetition from given 3 digits. These are different cases. So suppose you are given 5, 6, 7, these 3 digits, and you have to make
2-digit numbers.
the possible numbers are 5, 6, 5, 7, then 6, 5, 6, 7, 7, 5, 7, 6, because repetition is not allowed. So N of S is 6, which is nothing but selecting 3 or taking 3 from 3 digits, taking 2 digits and arranging 3p2. That is 6. N of S can be written as 3p2. That is 6. One more event, drawing 1 or 2 or 3 cards from a pack of 52 cards. The sample space will be, when you take sample space, if you have to draw 1 card, then that can be drawn in 52 C1 ways. Plus, when you want to draw 2 cards, and you have to select from 52, you will be selecting 2 cards. Plus, when you want to draw 3 cards from 52, you will be selecting 3 cards. So when you take the total, that many number of elements you will get in N of S when you add up all these. The next is, trial is nothing but an experiment. When you're conducting an experiment, it's a trial. There are different kinds of events, like certain event, which will certainly happen. In an experiment, a certain event
Certainly happens.
For example, when you are throwing a coin, getting head is a certain event. Then next is impossible event. So that can never happen. For example, when you are throwing a die, getting 7 is a thing which never happens. The next is complement of an event.
Suppose
S is sample space. A is event. then complement of event A is A dash, and that will be from
S, you will be removing A. For example,
in case of die, the sample space is 1, 2, 3, 4, 5, 6. And then getting even number is the event A. So getting 2, 4, 6 is event A. So A complement will be from S. You have to remove 2, 4, 6. These 2, 4, 6 are removed. So left is 1, 3, 5. This is A dash or A complement.
or complement of A.
Now, if an event A is given, probability of the event, probability of event A is P of A.
And P of A
Is given as number of favorable cases
over
total number of
cases
which are equally likely.
that's the probability.
For example, when a die is thrown, the sample space is 1, 2, 3, 4, 5, 6. So all equally likely cases, total number of equally likely cases, 6.
If the event A is
If the event A is just 1, 3. So the favorable cases in the event are just 2. So probability of A will be number of favorable cases by total number of equally likely cases. That is 2 over 6.
or 1/3.
Probability, instead of writing probability, from now onwards, I'll just write P in short.
So what I want to tell you is
Probability of impossible event that can never happen is 0.
and
Probability of sure event, the event
that can happen surely is 1.
the next thing or the next topic is about mutually exclusive
Events. If there are
two events, E1 and E2.
if the happening of one
Excludes the happening of other. That is, if E1 happens, E2 cannot happen. Or if E2 happens, E1 cannot happen. Happening of one event excludes the other.
such events are mutually exclusive events.
That means E1 intersection E2 will be 5.
For example,
E1 is an event that is sum of 5.
So in the event, we will have
1 plus 4, 5, 2 plus 3, 5, 3 plus 2, 5,
4 plus 1, 5.
Next, E2 is a sum of 7. So it has 1 plus 6, 7, 2 plus 5, 7, 3 plus 4, 7, 4 plus 3, 7, 5 plus 2, 7, and 6 plus 1, 7. You can see that there is nothing common in E1 and E2.
Even intersection E2 is
5. So we can say E1 and E2 events are mutually exclusive. Next, we can go to exhaustive events.
What are exhaustive events? Exhaustive events are those if the performance of the experiment always result in the occurrence of
At least one of them.
What do you mean by that?
A set of events. A set of events happen and they are exhaustive events. That means
if you perform an experiment, it will always result
in the occurrence of at least one of the events.
Next is probability of
A union B
is probability of A
plus probability of
B
minus probability of
A intersection B. Probability of A union B
can be just probability of A plus
probability of B
if A intersection B is empty set, or A and B are mutually exclusive events. Next is probability of A union B union C is probability of A plus probability of B
plus probability of
C minus probability of A intersection B
minus probability of B intersection
C minus probability of C intersection
A
and plus probability of A intersection B
intersection C.
Probability of A union B union C can also be written as probability of A plus probability of B plus probability of C if A, B, C are mutually exclusive events.
Next,
probability of any event will be always greater than or equal to 0
and less than or equal to 1.
Probability of A bar, that means probability of not happening of event A. So probability of A bar
can be given as 1 minus probability of A.
Probability of A union A bar
is probability of S, which is 1.
Probability of empty set is 0. Probability of A intersection B will be probability of A into probability of B. If A and B are independent events. Next,
Probability of
exactly one of AB occurs
is
probability of A union B minus probability of
A intersection B.
or
It is also given as probability of A bar union B bar
minus probability of A bar intersection B bar.
Probability of AB event will be less than or equal to
Probability of A,
which will be less than or equal to probability of A plus B,
which will be less than or equal to probability of A plus probability of B. Probability of A bar
intersection B
is probability of B minus probability of A intersection B. Probability of A intersection B bar is probability of A minus probability of A intersection B.
Next,
If
B is subset of A,
then we can say
a few things like probability of
A intersection B bar
will be equal to
probability of A minus probability of B. This happens only if
B is subset of A.
And probability of B will be subset of probability of A.
For sure.
Next, if P is probability of happening of an event and Q is probability of not happening probability of not happening of the same event.
Then I can say P plus Q
Equal to 1 and P is between 0 and 1. So the next is conditional probability. Let A and B be two events and S be sample space. Then probability of event B when event A, I'll write again. When event A has already occurred is conditional probability
of B
and is denoted by
probability of
B by A.
like this.
To understand this, we have to go through one example. Then you will understand what is conditional
Probability.
Suppose in a box there are 8 tickets. These tickets are numbered 1, 2, 3, 4, 5, 6, 7, 8. One ticket is drawn at random. So you are drawing one ticket at random. And it is kept aside. So this will affect in the second draw. Then second ticket is drawn. The question is, find the probability that both are even numbers. That you have to find out. So total number of tickets, sample space, we have 1, 2, 3, 4, 5, 6, 7, 8. The tickets with even number 2, 4, 6, 8. If A denotes both tickets showing even numbers and B denotes first ticket showing even number, C denotes second ticket showing even number. So probability of B will be N of B by N of S. Even numbers are just 2, 4, 6, 8. So 4. Total 8. So 1 by 2 is the probability. Now after B has happened, next what happens is N of S has only 7. Right? And then N of C, because out of 4 even numbers, one even number is already taken. Total, how many even numbers are there? 2, 4, 6, 8. 4 even numbers are there. But now, only 3 even numbers will be there. Right? So, N of C, only 3 even numbers. Probability of C will be N of C by N of S. That is 3 by 8. sorry, not 3 by 8, 3 by 7. Because now total only 7 numbers are there, 3 by 7. So the required probability of A will be both tickets showing even numbers. That is, first ticket showing even number probability, second ticket showing even number probability. And that is 3 by 14. This is how we have conditional probability. But there is definition of conditional probability. Probability of B given A is probability of A intersection B by probability of A. Probability of A given B. It's probability of A intersection B by probability of B. Now, based on this, we can say odds in favor of event A is probability of A by probability of A bar. Odds against happening of event A is P of A bar by P of A. Next, A and B are mutually exclusive events. If we have A and B mutually exclusive events, and A and B are exhaustive events. Exhaustive events means A union B will be equal to S. Then probability of A plus probability of B will be probability of A union B. That is probability of S. That is 1. Probability of S is 1. Therefore, we can say probability of A plus probability of B will be 1. Next, if A and B are mutually exclusive events, then probability of A intersection B is probability of phi, that is 0. So we can say probability of A intersection B will be 0. Then we will come to distribution. In distribution, we will come to learn about random variable and probability distribution. This you will understand better while doing problems, not now. First of all, what is random variable? If we take U or S as sample space, then A real valued function
x
is defined on U
or s.
that is x is the function from U to R. This is called random variable. There are two types of random variables. One is discrete random variable. The other one is continuous random variable.
What is discrete random variable?
In this function, the range
Is
finite set
or
infinite sequence of real numbers. Then we call
discrete random variable.
for continuous
Random variable,
in this function, if range is an interval a comma b
of R.
Now
The thing is,
we can find probability distribution of random variable. So what happens is there is a function
which joins U to R.
Suppose x
assumes values in the set.
assume values means
X takes values
like x1, x2, xn.
which is subset of R.
So in turn, x assumes
Size.
then p of
Xi
probability
of Xi
is probability of xi
in X. Probability of Xi will be greater than or equal
to 0. I will be 1, 2, 3 up to n.
and
Sigma of probability of xi I equal to 1 to n
will be always 1.
If you take the set of
Real values
p of x1, p of x2 up to p of xn, this is only called probability distribution of random variable, that is x1, x2 up to xn. This can be understood better if you write a table. That is x equal to n. You will write x1, x2, x3 up to xn. And p of x, you will write p of x1, p of x2, p of x3 so on up to P of xn. So you have to make a table like this. That will be better to understand because there will be many probabilities in this. Let us take one example.
Suppose if P of x I give you 2x by n into n plus 1, where x I will say it is 1, 2, 3 up to n.
Then P of 1 plus P of 2, etc. up to P of n. That will be 2 by n into n plus 1 into 1 plus 2 plus 3 up to n. So this is 2 by n into n plus 1, and the formula here is n into n plus 1 by 2. So this gives you 1. You can see probability of 1 is greater than or equal to 0. Probability of 2 is greater than or equal to 0. Probability of n will be greater than or equal to 0. So here P of x is probability distribution. Similarly, I'll give you another example.
Suppose if I give you a probability distribution of
Random variable x,
in the form of a table,
x equal to n, minus 1, 0, 1.
and
Probability of x as 6b,
4b,
2b. We have to find b. Then we know that probability of negative 1 plus probability of 0 plus probability of 1 will be equal to 1. That is 6b plus 4b plus 2b equal to 1. 12b equal to 1, or b will be 1 by 12.
mathematical expectation.
What is mathematical expectation?
In this itself,
Suppose if there is a table x equal to n, which has x1, x2, x3 in the table up to xn. And we have probability of x in the table, p of x1, p of x2, p of x3 up to p of xn. So each p of xi will be greater than or equal to 0,
and sigma p of xi
I equal to 1 to n
will be equal to 1.
So mathematical
Expectation E of x
is sigma xi into p of xi, I equal to 1 to n. This is only called mathematical expectation.
So basically, mathematical expectation of x is
Expected value of x. It is expected value of x or mean of x.
that means
If y is g of x, then expected value of y will be e of g of x. That is sigma g of
xi into P of xi, where I equal to 1 to n. Similarly, E of x square will be sigma xi square P of xi, I equal to 1 to n. Then variance, that is V of x, or sigma x square, will be E of x square minus E of x whole square. Standard deviation. So standard deviation will be nothing but square root of V of x, or just sigma x. That is standard deviation. From these, there are some results which are obtained. That is, if y equal to ax plus b and z equal to ax square plus bx plus c, then mathematical expectation of ey is expectation of ax plus b. That is a into expectation of x plus b. Sigma y square will be v of y. That is a square into v of x. That is a square into sigma x square. Sigma y square will be equal to square root of v of y. That is mod of a sigma x. Mathematical expectation of z will be expectation of ax square plus bx plus c, which is nothing but a into expectation of x square plus b into expectation of x plus c. This you can understand only with the help of example. Quickly, I will give one example. I'll give you a table x equal to n having minus 1, 0, 1 and probability of x as 0.24, 0.48, 0.28. So mathematical expectation of x will be sigma xi into p of xi. That is minus 1 into 0.24 plus 0 into 0.48 plus 1 into 0.28. Using calculator or simply like that, you will get negative 0.24 minus 0.24 plus 0.28, which is 0.04. Now the variance will be sigma x square. That is xi square into p of xi minus sigma xi into p of xi whole square. So xi square minus 1 square into 0.24 minus 0 square into 0.48 plus, sorry. And then plus 1 square into 0.28 minus whatever sigma xi into p of xi we got, 0.04 whole square. This, I'm writing it here. So this will give me 0.24 plus 0.28 minus 0.04 whole square. And this will be 0.52
minus
0016. This is 0.5184.
So in this way, I got sigma x
Square as 0.5184.
So mathematical expectation of
X is nothing but mean of the distribution.
In the next class, just we will learn about binomial distribution a little bit.
And then we can go to the
multiple choice questions. With this, we end our class.